To arrange and position the elements in your user interface, you use layout panels. A layout panel is a container for your elements. The most important layout panels available in WPF are Stack Panel, Grid, and Canvas. In this clip, let's take a look at these three panels and let's start with the Stack Panel. So let's create a stack panel and let's say that this dark rectangle is the area of the created stack panel. Let's use the property element stackPanel.children to add two light blue rectangles to the stack panel's children property. Both rectangles have a height of 20 and a margin of 2 pixels. The stack panel stacks these two rectangles vertically like this. Now let's look at the property element stackPanel.children. The children property is defined in the panel class, which is the base class for all WPF layout panels. The panel class defines the children property as a content property with the content property attribute. This means that you can omit this property element. This makes your SAML code more compact. By default, the stack panel stacks elements vertically, but if you set its orientation property to horizontal, it stacks elements horizontally. Instead of setting the height properties on the two rectangles, let's set the width properties to 20, as setting the width makes sense when you have a horizontal stack panel. Now the stack panel arranges the rectangles like this. As you can see, the two rectangles are stacked horizontally. The stack panel is great for simple things, like for example to stack an OK and a cancel button. But to build the main layout for a user interface, there is a better panel, and that is the grid. The grid is the most powerful layout panel in WPF, and you will usually use it to arrange the elements in your main window. Now let me show you how the grid works. So let's define a grid here. The grid allows you to position your elements in rows and columns. To define rows, you use the grid's rowDefinitions property with the property element grid.rowDefinitions. In this case, I have added two rowDefinition elements. This means that you get a grid with two rows. Creating columns in the grid works the same way. You add column definition objects to the grid's column definitions property. In this case, the grid has now also two columns. Note that you can also see the lines that I draw here for the rows and columns in your running WPF application by setting the Show Grid Lines property on your grid to true. You should do this only to debug your application. If you don't set this property, you can still see the lines and the grid's rows and columns by using the WPF designer of Visual Studio. I draw these lines here so that you have a clue what the grid actually does. Now let's look a bit more detailed at the row and column definitions. A row definition has a height property and a column definition has a width property. We haven't set those properties, which means, for example, that the two columns have exactly the same width. Let's set, for example, the width property of the first column definition to 40 pixels, and this changes the grid to this. Now let's add a light blue rectangle to the grid. This rectangle is placed by default in the first row and in the first column. But the rectangle can inform the grid in which column the grid should put it. This is done with the attribute grid.column that is set here to 1. Now the grid knows that it has to put this rectangle into the second column as the first column has the index 0. The attribute grid.column is a so-called attached property. It is a column property that is defined in the grid class, but that is not set on the grid itself. Instead, it is attached in this case to the rectangle. The grid reads that property value so that it can position the rectangle accordingly. As you can see, the syntax for an attached property is className.propertyName. In this case, grid.column. All layout panels that we look at in this clip provide attached properties, except the stack panel. Beside grid.column, you can for example also set grid.row to 1, which moves the rectangle to the second row of the grid. So this is how the grid works. The grid is quite often used as a root panel. Usually, you nest other layout panels in the grid. So here for example, instead of the rectangle, you could also add a stack panel to the grid, and then the stack panel itself could contain other elements and also other panels. So you see, to build a layout, you usually nest different layout panels. Now let's also look at the canvas. The canvas is used to position elements absolutely. Let's create here a canvas that contains a light blue rectangle with a height and a width of 50. The canvas positions this rectangle in the top left corner. On the rectangle, you can set the attached property canvas.left to 50 to move the rectangle 50 pixels away from the left side of the canvas. You can also set the attached property canvas.top to, for example, 100 to move the rectangle 100 pixels down from the top. Now let's add also an orange rectangle with the same size to the canvas, so this rectangle is now in the top left corner. Let's set canvas.left to 75 to move it away from the left side, and let's set canvas.top to 125 to move it away from the top. Now you can see that the orange rectangle is rendered on top of the light blue rectangle. This is because the orange rectangle is added to the canvas after the light blue rectangle. The SAML document is read from top to bottom. To get a different behavior, you can change the order of the rectangle elements in SAML, or you can set the attached property panel.setIndex on the blue rectangle to a value that is greater than 0. 0 is the default value for the setIndex property. As you can see, now it is set here to 1. With this value, the blue rectangle is rendered on top of the orange rectangle. The canvas is a fantastic panel to position shapes like rectangles, ellipses, lines, and polygons. With the canvas and these shape elements, you can create nice drawings and diagrams in your WPF application. But the canvas is not a good choice to position UI elements like text boxes and buttons. This is because the canvas positions elements absolutely, which means it does not adjust an element size if there is more space available. But maybe you want, for example, that a text box grows when the panel gets more space. That won't happen if the text box is in a canvas. But if you put the text box, for example, in a grid, it can grow and shrink. Now you learned the basics about these 3 WPF layout panels. In the next clip, you will learn how to build the layout for the customer's application with grids and stack panels.